Welcome to this lecture, and in this lecture we are going to talking about the data structures in C++. The data structure can be defined as an organized collection of the data that helps a program to access data efficiently and rapidly, so that the entire program can function in an efficient manner. As you can see on your screen that the need for the data structures. I just told you that data structure is an organized form of data which is a more efficient for the programs and which is used for the more powerful computers and more complex applications. Data structure is also a collection of the data to the application. We just see the organizing data. An organization for a collection of record can be searched, processed in any other or modified way. The choice of data structure and algorithms can make the difference between a program running in a few seconds or many days. Let us see an example that a person who are making a bank account. At the first day, he do make a bank account, he do transaction, and at the same day he close the account. This is a simple example that how a data structure work. As first stage, he make the account, he do transactions, and he close this account. Here a data structure is needed to check the data of the customer, to check the transaction, and if he want to close the account, so he will check the closing of the account here. So data structure is used for that purpose. We know that in a programming world, a data is a entire, or maybe you say that this is the center of everything, which is revolves around the data. We need to do all data operations including storing, searching, sorting, organizing, and accessing the data efficiently, and only then our program can succeed. You can see the efficiency of the data structure right here, that our data structure is more efficient. A solution is said to be efficient if it is solve the problem within its resources and constants. Why we see data structures are more efficient? Because it's take less space and less time. The less space and less time means in less time you will make more softwares. The productivity is increased right here. The cost of a solution is the amount of resources that the solution are consumes. Let's just see the space. Here we have a stack. We will learn about the stack in next upcoming lectures, and in a same lecture this is the stack or queue. This is a queue and this is the stack. You see, this is the stack. Stack and queue both are using for the data structure. Let's just see, we have U, A, B, C, D numbers are here, and our one field are or two fields are or three fields are empty. Okay, so these are our indexing, like 1, 2, indexing start from 0, 1, 2, 3, 4, 5, 6, and 7. You can see if you want to allocate the memory to the U, let's just see, I just start from 200, so that will be the 201, 202, 203, 204, and these spaces are empty. So data structure will be leave these spaces and take only the memory location of these. This is just a called data structure. So same like a stack right here. As I just told you that data structure is the most efficient and less memory consuming. So that's why the programmer are liking the data structure more than a structural programming or a functional programming. So selecting a data structure, so analyze the problem to determine the resources and the constants. A solution must meet the data structure. Determine the basic operations that must be supported. Quantify the resource constant of each operations. Selecting the data structure that best meet up the requirements. Some questions to ask about the data structure. Are all data structure inserted into a data structure at the beginning? No. At the beginning, there are not all data structures are inserted, because at the beginning we just not need a complex applications. Interspersed with other operations? No. Can data be deleted? Yes, you can delete the data. Are all data processed in some well-defined order, or is a random access allowed? Yes, it is allowed. Let's just go to the one example. For example, we have a student right here. So I just represent a student as the STD. So that can have the following details, like he have roll number, name, age, class, and grade. In name, he have more two fields, which is first name and last name. Here see the logic. We have the data here, group items here. We have to save the records of all these datas. You can see we have to save all the record in student of all these data. We have the entities right here. We have the attributes or fields right here. And we will make the student files right here. For that purpose, we need the data structure. In data, it is the elementary value. Like as you can see here in the figure, like student roll number, name and age can be a data. We have the group items as you can see here, which is first and last name. We have the entire record of the data, which is roll number, name, age, class, grade, etc. We have the attributes and the properties of these data. We have a file collections of these all data, like this is the one student. Then we have 2, 3, 4, 5 and 6 and up to 1000 and 10,000 students record. So you will make the file of that data. Beside that, why we need data structure in the programming? Because the data structure is searching the large amount of data. Data structure is speed up the programming processing. And the data structure is handle multiple and simultaneously requests. Let's just see the data structure philosophy. I just told you that the data structure is a programming effort. That is, speed up your program. Data structure can consume low space, and the data structure is less time consuming. That's why the data structure is a programming choice. As you can see here, this is our example that a person opening the bank account for a few minutes. After a few seconds, he will do the transaction and he will close the account over the night. This is a simple example of the data structures right here. A data structure is a physical implementation of an ADT, and each operation associated with the ADT is implemented by one or more subroutines in an implementation. Data structure is usually referred to the organization for the data in main memory, and a file structure is an organization for a data on peripheral storage such as a disk device. We have the logical and the physical forms in the data structures. Data items have both a logical and the physical forms. The logical forms are the definition of the data items within an ADT. For example, the integer and the mathematical signs like plus and minus. Physical forms are the implementations of the data items within the data structures. For example, 16 divided by 32 bits integer or overflow. We have the example of the stack. We studied stack in a few minutes ago, but there are no such descriptions right there. We have the stack right here. Stack is just like this one. Stack is a linear data structure in which the element can be added or removed only from the one end, which is called the top of the stack. If you want to insert any of the value into the stack, so you can call it the push operation. And if you want to delete any of the value from the stack or remove any of the value from the stack, you can call it the pop operation. Stack is a LIFO concept, which is last in and first out. Hope so you understand now. Let's just turn to the queue. Queue is a yet another linear data structure, which is used for the data structure in which the elements are added at one end, which is called rear. Let's just make a queue. This is called the queue, where you can add the element, so it is called rear. And if you want to delete the element, so this is called front. So the front in the queue, you can delete the element, or you can call in queue and dequeue. The concept of the queue is FIFO concept, which is first in and first out. Let's just see the real life example that a person who is entering the queue first will out the queue first. Hope so you understand now with this example. There are some implementations of the queue. Let's just see, you are adding the value into the front like 20, 5, 12 and 17. So if you want to delete any of the value, so you can move like this one, or if you want to add any of the values with the help of rear, so you can add like this. Like here I just want to add 18, then 19, then 20 again, then 21, then 23. If you want to delete the value, so you can move like this one, like first one is a 20, then 5, then 12, then 17, then 18, then 19, and then 20, and then 21 and 23. You can move like this one. Okay, hope so you understand now with this example. If you find any of the problem regarding to the stack or a queue or a data structure in C++, please let me know, and thanks for watching this lecture. Welcome to this lecture. In this lecture we are going to talking about the stack data structure in C++. A stack is an abstract data type with a bounded or predefined capacity. It is a simple data structure that allows adding and removing elements in a particular order. Every time an element is added, it goes on the top of the stack, and the only element that can be removed is the element that is at the top of the stack, just like a pile of objects. As you can see here on your screen in the picture, this is, you can see we have the stack. At the top element, you can say that this is the top of the stack. If you want to add any of the element into the stack, this operation is called push operation. Or if you want to remove any elements from the stack, so this is called pop operations. A stack is an ordered list of similar data type. A stack concept is last in and first out. You can see here, this is the last in, and that will out when we just removing elements, so that will remove for the first. So this is simply the concept which is called LIFO, or you just say that this is FIFO. So filo means first in and last out. You can see this is first in and last out. 1, 2, 3, 4. So that will remove at the last. This push function is used to insert new element into the stack, and the pop function is used to remove an element from the stack. Both insertion and removal are allowed at only one end of the stack, what you just called the top. So you can only remove these elements from the top. A stack is said to be an overflow state when it is completed fully, and it's said to be the underflow state when it is completely empty. Let's just see, we have stack 1 right here and we have stack 2 right here. If this stack is completed, so we just say that this is overflow, and if this stack is empty, so this means that this is the underflow. The applications of the stack is, the simple application of the stack is to reverse a word. You push a given word to the stack like letter by letter and then pop letter from the stack. So there are other uses also for the application of the stacks are parsing and expressions conventions. So that will call the prefix, postfix, and you can say that yes, prefix and postfix, etc. Let's just see the implementations of the stack data structure. I just remove these all. So stack can easily implemented using the array or the linked list. Always are quick but the limited in size, and the linked list requires the overhead to allocate the link, unlink and delocate, but is not limited in size. Hence we will implement stack using the array. So we are see that we have stack number 1 right here, then stack number 2 right here, and then stack number 3 right here. Hope so you understand now. We have 3 types of stacks right here. Let's just see, here I just create one another stack, and this stack is the empty stack right here. This is the top of the stack right here, and I want to add an element in the stack which is 6. So I just add this element with the help of this top of the stack. So now my 6 is added right here. So my stack is adding 1 value right here. Then I just want to add 7 right here. You can see I just add 7 right here. Firstly, I just define the stack of 4. Okay, this is a stack of 4 elements. Then I just add 2 and I just add 1. Okay, this is the simply insertion of 4 elements right here. If I want to add now 4 right here, you can see this element, so that stack will be overflow. After this one, that stack will be overflow right here. Okay, hope so you understand now. Or if you want to delete an element, so firstly 4 will remove, then 1, then 2, then 7 and then 6. Hope so you understand now with this example. In stack, all operations take place at the top of the stack. The push operation added an item to the top of the stack, and the pop operation is also removing the items from the top of the stack. Remember that. Now we see the algorithms of pushing the operation and popping the operation. First, it will check the stack is full or not. Let's just see, we have the stack right here, so it will check that this stack is full or empty. So this is the empty stack right here. This algorithms work like this. If the stack is full, then print the error is you have the overflow stack, and that will exit the program. If the stack is not full, then increment the top and add the element. What is the algorithms of pop operation? It will check if the stack is empty or not. Then if the stack is empty, then that will print the error of underflow and exit the program, like pop operations. If the stack is not empty, then that will print the value of the element at the top and decrement the top. Now we go to the coding example of stack data structure. Here we go to the code block, and now here I just write hash include and IOStream. Close this code right here. So I just write this program for the stack, or this is simple implementations of the stack data structure with the help of object-oriented programming. Now here I just write using namespace std. Okay. Now I go to integer and main function right here. Now inside the main function, I just said that this is a stack and stack name is S1. Now I go right here and create the class name, which is stack. So this is a simple representation of the class. You can simply implement your class like this. So integer, which is on the top, and then here I just write public. So this is access specifier integer a, and this is the array. I just told you that you can implement the stack using the array. So this is a maximum size of 10, or you may say this stack is the maximum size of 10 right here. Now I just write that stack, call the stack right here, create a new function, and here I just write top, which is equal to -1. Okay. Now after this, I just declaring the functions right here. So here I just write void, and void is the push function right here, and I just pass the parameter to this function, which is integer x. Now I just define this function right here, which is s1 dot push, and the push size here is 10 also, because we have the 10 digit stack here, or we have the 10 elements stack here. Now I just write that this is integer pop. Okay, and void is empty, or I just said that this is void is empty. So our this function, or this class for stack is completed right here. Now I just go to the main function, and here I just write that s1 dot push, and push 100 values right here. Now we go back to our function, and here I just create a module, or you may say I just create a functions to insert the data into the stack. Now void stack push, which is integer x. So first of all, I just pushing the values right here, which is integer x, and now I just write that if top, which is greater than or equal to 10, then cout, which is print that stack is overflow, and print the single line break right here. I just set the else statement right here, which is a, and then increment operator right here, which is equal to x. So you just simply write the increment statement before or after the top. Okay, it's up to you. So cout, which is here I just write element inserted, which is /n. Okay, hope so you understand now. So what is exactly the mean here, which is the stack push an integer x? As you can see here I just take a function which is for inserting the data into the stack. Firstly, it will check that this stack is overflow. So simply it will give you the message, means if we have the already 10 elements inside the stack, so it will show us this error. If this stack is not overflow, so that will go to the inserting the elements right here. Now go through another function. Now here, firstly I just create the functions to insert the data. Now I just create a functions to remove the data from the top of the stack, because we are just removing or adding the data from the top of the stack. Now stack which is pop, and then here I just write if top which is less than 0, and here I just write that cout which is stack underflow /n. Close this code right here and return which is 0. Now I just go to the else statement, and the else statement here is integer d which is equal to a, and this is the top minus minus, and that will return d right here. Okay, so I just simply create a functions to removing the data from the stack. Now here I just create void stack again. This is our function name right here to check that function of the stack is empty or not. Here I just write is empty, and then here I just write that if top which is less than 0, so cout that this stack is empty, and here is write /n for the single line break, close this with the semicolon. Okay, now show. Now after that we go to the else statement, and if this stack is empty, so that will print this statement, and if this stack is not empty, so that will go to the another statement which is cout, and that will set that stack is not empty which is /n, and close this code right here. So here if you want to perform any of the actions, so you want to add, so simply add it right here. But here we have created the functionality of these all, so let's just check. So we have an error, I just forget to add the semicolon right here, and yes, my program is running right here. As you can see here, firstly I just simply insert the libraries. You can see my program is running right here, which is element inserted. Firstly I just create the class of stack right here. You can see first I just define integer top, public all the things like all the variables, integer a, and then I just take a functions right here, so this function is stack, and then write that top which is -1, so this one. Okay, so now after that I just add that push integer x, and then pop, and then element. So I just simply create these three functions right here. Then after that I just remove this. Then after that I just create another function name which is stack for push. You can see here, and then if the top is greater than 10, so that will simply show us the message which is stack is overflow. Then element If this statement is not true, then that will go to this statement, which is element is inserted. Then we create for deleting the elements from this stack, and at the last I just said that this function is for emptying the stack, and I just call these all functions right here in the main body. So let's just close this program, and now we will run it again. So you can see here all elements are inserted right here, and your program is working correctly. Hope so you understand now with this stack example. If you not, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to talking about the queue data structure in C++. Queue is also an abstract data type or a linear data structure. Just like a stack data structure in which the first element is inserted from the end, which is called rear, and this is also called the tail, and the removal of the existing elements takes a place from other end, which is called front, and you may say also this is the head. The concept of head and tail, which is used in queue and stack. So this makes queue as first in and first out in the data structure, which means that the element inserted first will be removed first. Like if you add the first element right here, so that will remove the first element, simply like the queue. I will show you the diagram of this stack and the queue right here. Like here you can see if you want to adding the element from here, or if you want to adding the element from here. So like here, if you want to add the element, so this is called front. Okay, sorry, this is called rear if you want to add the any elements from this one, or you may say this is also called the in queue operation. And if you want to delete the element from here, which is called the dequeue operation, so this is called front. So the front is also called head, and this is called tail. Okay, hope so you understand now with this concept of the head and tail and the front and rear. Now this make, I just told you that this queue will make like FIFO concept, first in first out. If you want to add any of the element right here, from that will go like this one, or if you want to add any elements from this one, so that will go like this one, first element, first in and first out, which is exactly how queue system works in real world. If you go to a ticket counter, like to buy a movie ticket, and there are first in, and you are the first in the queue, then you will be the first one who will get the ticket first, right? Same in the case like queue data structure. Data is inserted first, and that will leave the queue first. This process is to add element into the queue is called enqueuing. You can see this is called enqueuing, and the process of removal the element from the queue is called dequeuing. In stack, you can add elements from here, and you can add elements from here. It's up to you. Okay, hope so you understand now. Let's see the basic feature of this queue, that how this queue is work. First of all, I just told you that like stack, queue is also an order list of the element of the similar data types, and queue is a FIFO concept, first in and first out in the data structure. Once a new element inserted into the queue, all the element inserted before the new element in the queue must be removed. To remove this new element, you just simply execute the first elements. Here in stack we use peek function, we use peek function, which is often to return the value of the first element without dequeuing it. Hope so you understand the concept of the queue. I just remove these all, and let's just turn to the coding example. Here we have hash include and iostream. Then I start that using namespace std. So now here you can see I just create stack 1, stack 2, sorry, q1, q2, q3 and q4. Okay, or I just remove these two queues right here, and here I just said that this is queue number 3 and this is queue number 4. Okay, I just divide this queue like this one, and 1 2 3 4, and this is also 1 2 3 and 4, 1 2 3 and 4. Okay, and 4. So this is our head and this is also our tail. So I just represent H for head and T for tail. This is the indexing 0 1 2 3 4, same as the case like these all. If you want any of the element like this, simply I just said that this value is 2 right here, what I just want to add. It will go to the index 2, then add the next step, like here I just want to add the 2, then in the next step I just want to add 19 right here, 17 right here, or you just want to add 8 right here. So we have 1 2 3 4, means 0 to 3 index right here, and I just add these all elements on this elements here. Now we have the head right here. Head is the front. Okay, and if you want to add any element in the next index, so simply you just want right here. Now how we are just removing the elements from the stack? Simply you just add, like here I just add 10 right here. So simply when I just removing, so simply 2 19 17 8 and 10 will be executed like this. I just want to remove the element 2 right here. Okay, so I just remove this 2, so the stack will be 19 17 8 and 10. Or if I want to remove the element 19, so this stack will be 17 8 and 10. So like this one. Hope so you understand now with this concept of removing and adding the elements from the queue. Now we just turn to the coding example again. Here you see I just define the size, sorry, this is the size of 10 right here, and then I just add that this is a class of queue, and then here I just write integer a, which is the array of size. Okay, and close this code like this one. Now integer, I just define rear for same like tail, and integer front, which is same like head. So rear is using like for adding the element, and front is for deleting the element. Now I just write that public and then queue. Okay, same like I just make a functions right here. In stack I just said that like top, which is plus plus, but here I just add rear, which is equal to front, and the front which is equal to minus 1. Simply removing the element, so I just said that minus 1 right here. Hope so you understand now. Now I just create a function which is a void function for in queue, which is in, okay, in queue. Now integer x, I just create the parameters for this in queue functions. So this is simply the declaration of in queue. I just go to the integer main, and here I just define q which is equal to q. Okay, now go back to the enqueue functions right here, and here I just define void enqueue integer dequeue, and at the last void display. Okay, closes core body. My functions are created right here, and no right here. So here I just write void queue function again, which is enqueue, and here I just pass the parameters which is integer x. So this function is simply to adding the element or adding the data into the queue, which is using as an enqueue. Now I just write that if statement, which is front for adding the element, which is is equal to -1. Okay, then I just said that front which is plus to adding the element, so it will add the element. Now if rear, and the rear which is equal to size, so simply minus the value of the size and print the value with the help of cout, which is q is full. Hope so you understand now. Now I just define that else, and the else here is a adding the increment operator, which is rear, and the rear which is equal to x. Now our this function for adding the element is completing right here. Now we simply go to remove the element. Okay, here I just said that integer q, and which is equal to dequeue. Now return is a, and this is the plus operator, which is front, and close this code right here. So this follow the approach B. I just told you that this follow the approach B, which is like there is no such overheated, but whatever we move had one position to another position, after removal of the element, the size on the queue is reduced by on space each time. Remember that. This is our B approach, and our A approach is there is no overhead of shifting the element one positions toward every time we remove the first element. Remember that these are the two approaches in the queue. So our this approach is working like here. Now I just remove this, and then here I just write void q. So this is the capital Q right here. So let's just see, we have, yes, small q, no problem. Now I just write here q for display the element. So this function is to simply display element, and here I just write integer I for loop, which I is equal to front, then I which is less than or equal to rear, and at the last I plus and close this code right here. Simply the approach of cout, which is a, and a will print the array of I right here, and at the last I just write that end line. Okay, so after this I just adding one curly bracket right here. Now we go to the main body, and here I just write q dot enqueue, which is which is 10. Okay, so this is the size of 10, which is q enqueue. Paste it again. We are just writing 100 right here, then 1000 right here, then 1001 right here, 1002 right here. Then I just write that dequeue the value. Okay, this is a simple adding the values into the queue and then dequeue the value. Okay, then I just write enqueue, which is 1003. Then I just said that dequeue the value 2 times, and then here I just write that enqueue the value, which is 104. And now here I just write q dot display and close this code here. Now return 0. Now check the output, and we have an error here, which is dequeue, which is dequeue and dequeue, and yes, okay. Run it again. So you can see here, after running this program, that will show us the result of this program, that how we are working with enqueue and dequeue operators. So you can see here, after this I just explain like this one. We have 1 2 3 4 5 6 7 elements. What I just add in the queue. First I just add 10. I just write that I just add 10 right here, or remove this, and here I just add 10. Then I just add 100. Then I just add 1000. Then I just add 1001. Then 1002. Then 1003, and at the last 1004. 0 1 2 3 4 5 and 6. Okay, after adding 1 2 3 up to 4 indexing, I just set to the queue that dequeue the value. So that will simply dequeue the value here. So it will dequeue 10. So we have the left values, which is 100, 1000, 1001, 1002, 1003, and at the last 1004. Then I just said that 2 times dequeue the value. So it will 2 times dequeue the value and remove 110 from here. Then it will print 1001, 1002, 1003, and 1004. And I just said to the queue, please display the value right here. So it will display us these false values here. Hope so you understand now with these approaches of the queue. If you find any of the problem regarding to this lecture, please let me know, and thanks for watching this lecture.